All right, let's talk about something you hear all the time: programming and coding. We kind of throw these words around like they mean the exact same thing, right? But do they? It's a question that trips up pretty much everyone at some point, from beginners all the way to people who've been in tech for a while.
So, are programming and coding the same thing? Well, the short answer is no, but it's totally understandable why we mix them up. The truth is, they're two sides of the same coin. Think of it less like a competition and more like a two-step process, a journey to bring an idea to life inside a computer.
And you know what? To really wrap our heads around this, we don't need some dense computer science textbook. Nope. We just need a super simple, everyday analogy. Let's imagine you're giving a friend directions to your house for the very first time.
Okay, let's start with the big picture, the grand strategy. This is where programming comes in.
See, when we talk about computer programming, we're talking about the entire process. It's way more than just typing stuff out. It's all the strategic thinking, the problem solving. It's taking a spark of an idea and figuring out how to turn it into a real working program.
And this is the really interesting part. Programming involves all this stuff before you even write a single line of code. You're analyzing the problem, you're designing algorithms, which is just a fancy word for a step-by-step plan. You're even checking how accurate that plan is. It's all the prep work.
So let's go back to our directions analogy. This whole strategic process, that's you standing there and planning the route for your friend. You're thinking, okay, should they take the highway or the side streets? What about rush hour traffic? What's the clearest, most foolproof way to get them here without getting lost?
That final step-by-step plan you come up with, turn left at the big oak tree, drive for 2 blocks, that is an algorithm. And creating those clear, logical step-by-step plans, well, that's the absolute core of what programming is all about.
Okay, so if planning the route is programming, what about actually giving the directions? This is where we get to the action. This is coding.
Coding is really the act of translation. It's taking that beautiful plan, that algorithm you've already figured out, and converting it into instructions that a computer can actually understand, using a specific programming language.
Going back to our friend, coding is the moment you pick up your phone. It's you typing out the text message with the directions, or making the call and reading them out loud. It's the physical act of communicating the plan.
So here's the big takeaway. Coding is a part of programming. It's just one piece of the puzzle. Think about it like building a house. Programming is the architect's job, designing the blueprint, figuring out where the rooms go, the whole shebang. Coding, that's the construction crew, laying the bricks one by one exactly as the blueprint says. One is the what and the why, the other is the how.
But okay, our analogy isn't perfect, because when we stop talking to our friend and start trying to give instructions to a computer, we run into a huge language barrier.
I mean, it's pretty obvious, right? Computers don't speak English. You can't just tell it what to do. At the end of the day, a computer is just a machine that runs on electricity.
And for a computer, the world is incredibly simple. It only asks one question. Is there electricity flowing right now or not? That's it. We call that on or off, which we represent with a 1 for on and a 0 for off.
This language of ones and zeros is called binary, and these little digits are called bits. They're the computer's alphabet. So when you and I see the number 5, the computer sees 101. Now, can you imagine trying to write a whole set of directions using just ones and zeros? It would be, well, basically impossible for us. So, that's the big problem, right? If we can't speak in ones and zeros, how on earth do we tell the computer what to do? We need some kind of bridge. And that bridge is what we call a programming language. You can think of it as a special middle ground language. It's structured enough for us humans to read and write, but it's also super precise and logical with no ambiguity, so that a machine translator can understand it perfectly. And that translator has a name. It's called a compiler or an interpreter. It's basically a special program that acts as our go-between. Its only job is to take the code we write and turn it into the raw ones and zeros,
what we call machine code, that the computer can actually execute.
So let's put it all together. Here's how it works. Step 1, we write our code in a programming language. Step 2, the compiler translates that code. Step 3, it spits out the machine code, all those ones and zeros. And finally, step 4, the computer runs those instructions. That's it. That's the entire journey, from a thought in our head to an action on the screen.
And this whole process isn't just some abstract theory. This is what makes everything around us work. The device you're watching this on right now, yep, the huge financial systems that run the world, life-saving medical software, even the robotic explorers on Mars. It all runs on this exact same principle.
So if there's one thing to remember, it's this. Programming is the thinking, coding is the doing. One is the strategy, the other is the execution. You really can't have one without the other. They're just two essential parts of the same amazing process.
So, now that you know the difference, it kind of makes you think, doesn't it? What amazing thing would you program? I really hope this helps you see our digital world in a whole new light.